The ocean is under extreme pressure from a variety of human activities over the last several decades. And as Professor Koutsoupas highlighted, there is compelling evidence that accelerating rates of ocean pollution, plastic contamination, overfishing, human noise, all have strongly affected marine ecosystems. Here I will focus on oceans' health in the context of climate crisis. So the ocean is a major component of the Earth's climate, playing a crucial role in climate variability. Currently, the ocean absorbs about 20 to 30% of the anthropogenic carbon emitted in the atmosphere, and importantly, it stores about 90% of the extra heat due to the global warming. However, the ocean and its living beings have to pay a hefty price for these mitigation actions for climate change. So the ocean warming induces severe changes in marine ecosystems simply because temperature controls biological productivity and many other processes in ecosystems. And for some of these ecosystems, such changes could be irreversible. So we have already extinct species, and we have a large number of species being currently critically endangered. Also, as the ocean carbon uptake increases with the emissions, the acidity of the ocean increases. Climate model predict that this acidification of the ocean will continue to increase in the future, and combined with ocean warming, this could have a devastating effect in marine species, especially calcifying marine organisms, in particular coral reefs, which of course among the most important marine ecosystems, providing habitat to more than 1 million species. The ocean is a highly dynamical system, so it's constantly in motion. And the ocean circulation, ocean currents largely control the ecosystem functioning because they distribute nutrients, inorganic carbon and other inorganic material, and of course heat. Importantly, the ocean, together with the atmosphere and the biosphere, are highly nonlinear and complex systems. So this means that they seek equilibrium through a continuous interaction and dynamical feedbacks between their components. So a particularity of complex systems is that perturbations, changes in the forcing, can make these systems pass a critical transition, a tipping point, abruptly pushing these systems into a new equilibrium. And this transition is very difficult to reverse, even impossible to reverse. An example for our climate in the ocean is what we call the Atlantic meridional overturning configuration, probably the most important three-dimensional ocean current system. And this system transports tropical warm waters from the tropics to the northern Atlantic, regulating the continental climate. And observations clearly show that we have a weakening of this circulation over the last few decades. And recent research showed that probably this circulation system reached a tipping point. It's close to a tipping point, close to a critical transition. And this is very important because if this transition happens and we have a new equilibrium, this equilibrium will be with a very weak circulation, which means that the whole climate, especially in the northern Atlantic, will be deregulated. So regions, continental regions in North Europe or East North America will be much, much colder. The tropics will be much warmer. So another important issue that is when we have a drastic change in a component of the climate system, then this can trigger changes in the other components. And there is likely to be a domino effect involving a lot of different climate processes, leading to a deregulation of the whole climate system. Another component of the climate where we observe drastic changes, where we are close to a critical point, a critical transition, is of course the cryosphere equilibrium in the polar regions. So there we have unprecedented over long periods, thousands of years, unprecedented accelerated rates of ice retreat in the Arctic Ocean. We also have drastic decreases. So we have the ice sheet melting in the Greenland and in West Antarctica ice sheets. So all these are dramatic changes for this time scale. So we usually observe this kind of critical transitions in time scales of, let's say, tens of thousands of years, but never in 100 years. So this is a huge difference in time scales of these dramatic changes. Another consequence of global warming is also the intensification of the water cycle. So the ocean plays again a very important role in that, because 80% of water fluxes take place over the ocean. And under a warming climate, the atmosphere can hold more moisture, and as a result, we have an amplification of the mean pattern. So dry regions of the planet become drier, wet regions, precipitation-dominated regions become wetter. And together with increases in mean temperatures or rainfall rates, we have an increase in the extremes of rainfall, heavy rainfall events. And the frequency and the intensity of these extremes is projected to increase in the future. So even now, last several decades, we have evidence that the intensity, frequency, and duration of the Atlantic hurricanes is increased since the 1980s. And of course, we all witnessed the extremes over last summer. So we have extreme events, unprecedentedly extreme events, both flooding in some regions like Central Europe, or of course droughts in other regions like the Mediterranean region. So to conclude, I would like to say that our current response to climate change is rather slow and linear, and this is important. So most governments set long-term trends to reach a net zero carbon at mid-century. However, this linear response is very difficult to reverse the current accelerating rates of changes that we see, as I mentioned before. And because simply the climate system doesn't function linearly, functions in a highly non-linear fashion. So the only way to preserve our ocean, and of course its living beings, and of course preserve humanity, is to drastically change things. Change, of course, greenhouse gas concentrations in the atmosphere, and also pollutants, of course, in the ocean. Just to say that currently, so even all, let's say, the targets and pledges set, and even in the more optimistic, let's say, scenario of reducing emissions in the atmosphere, we are heading towards a warming climate of at least 2 degrees Celsius, more likely 2.5, 2.7. And from 1.5 to 2 degrees, the impact on the extreme events, in the frequency, the intensity of the events, is very large. From 2 to 2.5 is even worse. So simply because of the non-linearity of the system, how the system responds to these changes. So it's very important, and hopefully in the forthcoming summit, climate summit, in November, the participants will step up with more radical action, more drastic action, and more immediate action to tackle climate change. And even to stabilize our climate at 1.5 degrees will be clearly the biggest and the more challenging project for humanity in the 21st century. Thank you.